At the south pole of Jupiter lurks a striking sight, even for a gas giant planet covered in colorful bands that sports a red spot larger than the Earth. Down near the south pole of the planet, mostly hidden from the prying eyes of humans, is a collection of swirling storms arranged in an unusually geometric pattern. Since they were first spotted by NASA's Juno space probe in 2019, the storms have presented something of a mystery to scientists. The storms are analogous to hurricanes on Earth. However, on our planet, hurricanes do not gather themselves at the poles and twirl around each other in the shape of a pentagon or hexagon, as do Jupiter's curious storms. Now, a research team working in the lab of Andy Ingersoll, Caltech professor of planetary science, has discovered why Jupiter storms behave so strangely. They did so using math derived from a proof written by Lord Kelvin, a British mathematical physicist and engineer, nearly 150 years ago. If you went below the cloud tops, you would probably find liquid water raindrops, hail, and snow, he says. The winds would be hurricane-force winds. Hurricanes on Earth are a good analog of the individual vortices within these arrangements we see on Jupiter, but there is nothing so stunningly beautiful here. As on Earth, Jupiter's storms tend to form closer to the equator and then drift toward the poles. There's just more gas under the clouds. Jupiter also has heat left over from its formation that is comparable to the heat it gets from the Sun, so the temperature difference between its equator and its poles is not as great as it is on Earth. However, Ingersoll says, this explanation still does not account for the behavior of the storm. Saturn, which is also a gas giant, has one enormous storm at each of its poles, rather than a geometrically arranged collection of storms. The answer to the mystery of why Jupiter has these geometric formations and other planets do not, Ingersoll and his colleagues discovered, could be found in the past, specifically in work conducted in 1878 by Alfred Meyer, an American physicist, and Lord Kelvin. Meyer had placed floating circular magnets in a pool of water and observed that they would spontaneously arrange themselves into geometric configurations, similar to those seen on Jupiter, with shapes that depended on the number of magnets. Kelvin used Meyer's observations to develop a mathematical model to explain the magnet's behavior. Back in the 19th century, people were thinking about how spinning pieces of fluid would arrange themselves into polygons, Ingersoll says. The presence of anticyclonic rings causes the storms to repel each other, rather than merge. Ingersoll says the research could help scientists better understand how weather on Earth behaves. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.